This video is sponsored by Inmotion Hosting. If you'd like to sign up, there's a link in the description. I don't really know where to start this video. I guess it's kind of for like maybe budding web developers or somebody that's maybe interested in web development, or maybe you just have a cPanel account or a VPS or something and you want to set up a web page. Well, you may or may not, have already fooled around with that. And it's like, how do I get my files up there? It's like, well, you can FTP or SFTP or something like that. But I don't really like that. I want to have it integrated with a version control system. Look, the name of the game with computers is you don't need to do stupid repetitive tasks. Computers are really good at stupid repetitive tasks. Stupid repetitive tasks make people want to kill themselves. It's very bad. So we can sort of fix that. And one of the great tools, like as a programmer in anything, no matter what you're doing, web programming or anything, one really great tool for programmers is version control systems, meaning that you make a change to the code and you save it and you commit it into a system which will remember everything that you've ever done since the beginning of time on a project. And a really great one that Linus Torvalds uses for Linux and damn near everybody else on the planet is called Git. And so Git is a program. It's not a website. It's not GitHub. I'm not talking about GitHub. More on that in a sec. It is a program that helps you manage the source code for programs that you write or anything like that. I'm going to show you how to use Git to hook it up to your website so that when you make changes on your local website, if you're working on your website or whatever, that when you just commit those changes, you can push them to wherever your website is hosted and they will be deployed automatically. It's actually surprisingly simple. A lot of people think that you have to have GitHub or some other hosted Git repository thing to actually do that. Now, the difference between Git and GitHub is GitHub hosts Git repositories on the web and provides a lot of value-added functionality on top of your Git repo, things like bug tracking and pull requests where somebody wants to send you code to your program and say, hey, I made an improvement or a change or something to your program. Will you accept those changes into your stuff? So like in terms of collaborative stuff, GitHub is pretty cool, but GitHub is a commercial entity. There are, of course, less commercial entities. GitLab is a program that is exactly like GitHub, but you can download GitLab and run it on your own machine, or not run it on your own machine. You can run it on their machine. You can pay for monthly hosting, but it gives you some mobility so that if GitHub ever changes their terms of service or something that you don't like, you're basically stuck. I mean, you can take your Git repository, but it's sort of a pain to get out all of the other information. With GitLab, at least right now, if you do hosting with GitLab and you don't like it, you can pull your stuff out. But I think a lot of these are really overly complicated for what most people need. You just need to be shown a little bit of how to set it up on your own, and you don't really need these things. Or you can use these things in parallel to actually connecting your dev machine to your production machine in terms of like web development. So what I'm talking about is basically taking files from the local computer, which is what I've got set up on this side of the screen, this right here, doing your work here on the local computer, and then in one command, pushing them to the remote machine here. Now, I've already connected to this machine, and this is the production Wendell.tech machine, which is a cPanel server for Inmotion hosting. Now, if you haven't seen those videos previously, you should totally check those out. If you are going to, make a side business or whatever out of helping people with their web pages or hosting web pages, or you're going to have a lot of virtual domain, you really should check out a VPS that includes something like cPanel, if not cPanel itself. cPanel is pay-for software. It's kind of expensive for what it is. There's a monthly charge that goes with it. The charge is bundled in with your Inmotion hosting, but it's really a good deal for all that it does if you make a business out of it. If you're doing it on the side or you're messing around, unless you're looking to level up your skills and learn more, there are less expensive alternatives. But it is nice that the host is maintained, by Inmotion and updated and those kinds of things, so that like, oh, we need to upgrade the kernel, Inmotion will handle that for you. And cPanel basically gives you full control and full access to the machine within certain limitations and sandboxes in order to make the different user accounts on the system work. Now, for the account that I'm using here, the Wendell.tech account, it's just an ordinary account on the VPS. There's nothing special about it. We covered that in the previous videos. Now, one thing to note, your cPanel provider or VPS provider should support giving you SSH access to your account. This is something that is set in WHM. So of course for Inmotion, it's no big deal because you have full control over the server. You can do whatever you want. You can enable or disable shell accounts is what this is usually called, because you've got a Unix shell here, so it's a shell account. Sometimes it's a jailed shell. Sometimes shell is disabled completely. Sometimes you have to email them and say, hey, I want shell access, and they put you on a list. Whatever. We don't care about that for right now. So I'm going to show you how to do this on Git Bash for Windows. You can just download, it's like a Git shell, and it will give you a bash command prompt in Windows, but this is equally applicable for Mac OS. Like Mac comes with Git these days, but it's an older version. You want to use brew or something and install a newer version or download a newer version from the Git website. It also comes with a fantastically old version of bash because Apple, whatever. You can also install the Linux subsystem for Windows. The Linux subsystem for Windows is actually a lot more functional than the Git Bash command prompt. And of course, if you're on Linux, you're already, in the master race. Now, okay, first off, when you've got Git Bash installed, you want to run the command prompt, and then you want to cd to .ssh. So .ssh is your folder that contains all your stuff. Now, because this is a new installation, the only thing I've got in here is known hosts. So we want to do ssh keygen -t. Now T is the type of key, and I'm already going to get a lot of debate as to what type of key you should use. You should use RSA, DSA, the elliptic curve one that's not compromised by the NSA. I mean, I don't know. We're going to do -T RSA-B 4096 because reasons, but know that there's other stuff you can specify there for other types of keys. And that's going to make a 4000-bit key, 496-bit. And since I don't have an ID_RSA or an ID RSA.pub, it's going to make one for me. If I already had an ID RSA or an ID RSA.pub, don't override them because you might be using them and not realize it. We will specify a different file name in that case. And if we want to specify a different file name, we can just do -f and then something. In my case, since I don't already have an ID RSA or an ID RSA.pub for this demonstration, I'm just going to let it do its thing. It's going to generate a public and private key pair, and it's going to say, hey, where do you want to save it? So you get another opportunity if you want to, specify something other than that. Okay, I've set a passphrase. So this has created two files, a public key and a private key. Now the ID RSA key is your private key. You should protect it with your life. You should also generally not move that file off of the system on which it was generated. You can always generate more private keys on more other systems, but it is a security weakness to have the same private key across different systems. The idea is that the private key never moves. There's a mathematical relationship between your private key and your public key such that you can give somebody your public key, they can use their private key and your public key to encrypt a message, and in that case only your private key will decrypt that message because of the relationship between those two keys. Similarly, only their private key, if you use their public key and your private key, only their private key will be able to decrypt your messages that you create for them using their public key and your private key. That's public key encryption. And that's how SSH works. And that's sort of step one of why we had to do this. When you're creating your public key, it also asks you for a password. What is this password? There's another layer of encryption. So if somebody breaks into your system, they can steal your private key and run amok. It's a really bad situation. So the password that it's asking you for here will encrypt your keys with the password. So even if somebody steals your private key, it doesn't do them any good unless they crack the password that it's stored with. The other nice thing is that password never leaves this system in any way. So when you put in the password, it's a local operation on this system to do that. Now, it's not really super convenient to have to put your password in every time, and one of the things that helps mitigate that and does some other really cool stuff is something called an SSH agent. And so an SSH agent is a program that sits on your computer and sort of manages access to these files. So nothing really ever directly accesses these files. It just says, hey, agent, has this guy logged in a while? Am I authorized to use the key to do some communication here? And the agent will manage access. So it's another layer of insulation. But for the purposes of this video, I'm just telling you to read more about that later. For now, let's just proceed on with getting the thing set up. Okay, I've got my public and private key generated locally. Now, how do I tell the remote system, Wendell.tech on the Inmotion VPS, to let me in? Well, there's a .ssh folder there as well, but there's a file that we need to put the public key in called authorized_keys in the .ssh folder. So basically what I can do is copy the contents of idrsa.pub and put them in authorized keys. And authorized keys can contain more than one public key. So you want to do a blank line to separate those just to be sure. But one public key, blank line, another public key, blank line, another public key, blank line, will let you have more than one private key that is allowed to access this system. It's not really the public key that's letting you into the system. It is, you have to have the corresponding private key to actually get access to the system. That's how this works. So once we add the public key to the authorized keys file and make sure that the permissions are such that only the owner can read and write the authorized keys file, which is a mode 600 in Unix vernacular, then the SSH program will trust this file as being authoritative, and your .ssh folder also has to be mode 600 as well. So in our case, the Inmotion host did not have an SSH folder. We need to create that folder and change the mode on that folder to 700. Now 700 in the context of a directory means it's read, write, and list contents. So we're going to make it 700, meaning that only this user is allowed to do anything in this folder or list the contents of this folder. And then inside this folder, we're going to create an authorized keys file with permissions of 600, which is owner read and write only. Nobody else can do anything. And we added the public key that we just generated to that authorized keys file. Now, what's the result of this? Well, check it out. I've got my two systems pulled up here. I've got my remote system and my local system. So I've exited the remote connection to the Inmotion server, and both of my consoles that are up now are on the local computer. What I'm going to do is just SSH wendell.tech. And now I'm SSH'd in. Notice that I didn't have to enter a password or do anything else. That's because my agent is running in the background and I put in my password previously, and it knows to grant access to that. Optionally, if I didn't specify a password for my SSH key, then I don't even need the agent running and it'll just let me in. Otherwise, the password that it asked me for is the password that I set on my local key, not the password to the system. This is much more secure than having a password on a system on the internet. Passwords on systems on the internet, honestly, is a dead thing. You need to use keys for pretty much everything. Initially, if you use the password to deploy the key, I mean, that's fine, but then you can go and disable password login for your account in WHM or, through another thing. Not to get too far off the subject, but SSH is a really interesting program and you can do a lot of really cool stuff. So like, you can even specify that this public key or the corresponding private key is only allowed to run certain commands or to do certain things on the system, which is really, really powerful. You can do a lot of cool stuff with that, but that's a video for another time. We've got our remote connection and we've got our local connection, but we have nothing else. There's literally nothing else. So where do we go from here? Well, let's take a look at our web hosting. So this is what is going on right now on wendell.tech. If you go to wendell.tech, it's just index of /. There is nothing here, literally nothing. If we go back to our terminal windows, and we do an ls, we can see that there's a public HTML folder here. This is stuff. So I'm gonna just do touch blah, which makes a 0-byte file, and then let's check. Look at that, blah has shown up. I've touched blah. It's like, oh, this is it. This is all you need. I can just copy the files this way. Yes, you could. But again, let's spend a few extra minutes now so that we gain back tens or hundreds or thousands of minutes over the lifetime of this project. Now, I mentioned Git. What does Git have to do with this? We're going to set it up so that Git changes here on the local machine. We can push easily to the remote machine, but the remote machine is still set up in a fairly secure way. And this will, this is kind of a generic approach. So this will work for a lot of things, depending on what kind of work, what kind of CMS you want to run. I'm going to have some suggestions for that at the end. So first off, I'm going to make a new folder. And just by convention, I like to call it public.html.git. Public.html.git is going to contain the Git repository. This is kind of weird. This is like a detached head bare repository, kind of an unusual thing. The reasoning here is because normally Git creates a .git folder. If I were to do this in public HTML, then somebody going to the website /.git, like if I were to go to wendell.tech /.git, unless I had special rules set up, you would be able to pull this up. You would be able to pull up the Git repository, through .git there. You would be surprised how many websites will let you access their .git folder. It is better and much more secure if you're going to use Git to manage your public website in the way that I'm about to show you. Just a best practice to have that somewhere else, not under the web root, because you never know what kind of a security issue that's going to introduce. So now we're going to do git init-bear. All right, so this looks a little weird. There's not a Git folder here. Instead of Git init, where you get the .git folder, there's stuff in here. This is actually the contents of the .git folder, which is why we called it public HTML.git. Get it? See what I did there? I've had too many M&Ms. This is not good. So we've created a Git repository, but how do we deal with the fact that Git doesn't know how to do stuff? Well, we're going to set our work tree to public HTML, and we're going to set our Git dir to the same, to public HTML.git. All right, so check it out. We've declared our Git directory as public HTML.git and our work tree as public HTML. Now, no matter where we are, we can work with the Git repository, even though our .git folder is not where Git normally expects it. Look at that. Hello, look at that. We've got working Git. I've created a readme.md, which just has howdy in it. So I'm going to do git add readme, git commit -m initial commit. We've got our Git repository. Everything is good. Now, those declare commands, I don't want to have to run those every time that I log in. So how do we make it run automatically? Well, I'm going to edit the bash profile and make this part of the profile. So what we do, declare-x doesn't really enter into it, and declare-x is not exactly the right perfect command for this either. But hey, lazy, whatever. So in our bash profile, I'm going to specify those, and I'm going to export them. Just like path, just like you customize your path, I've got the Git work tree and the Git directory, and those are customized. So now every time I log in, it will know the public HTML is hooked up to a Git repository. So this is cool. Now, on this side, I can do git clone ssh:// Wendell at wendell.tech :public .git. I've git committed and I've git pushed it, which has pushed it back to the server. But wait, README still says howdy, what's going on? Yes, just because you push into a remote Git repository doesn't mean anything actually happens. What's missing here is you need a receive hook, and this is the underlying technology for a lot of webhooks, for example. So in public HTML.git, there's a hooks folder, and there are these sample hooks. These sample hooks don't do anything, hence the name sample in the file. And so we want to, on post receive, check out from the Git repository into public HTML. There is a post receive hook, and all that really matters, this is sort of the shorthand version of doing it. You set the Git work tree just like we do in our bash RC, but remember this is a receive hook, so the RC is not going to actually run. You create a file in your Git directory under hooks called post receive. There is a sample file in there, and you'll just do git checkout-f after specifying the work tree. Now the working directory, this is print working directory because I want to see what the working directory is when I'm there. You could also echo a message here that's like, hey, I'm getting ready to overwrite production or whatever. You can totally do that. Now there is an interesting quirk of this. When there is a big enough version mismatch between local Git and the remote Git, because like my local Git is much newer than the remote one. If you use like public HTML and public HTML.get, it will not actually work because of a bug in Git. Yeah, who knows? It's like, oh, public HTML, I need to like deconstruct the URL or something. I don't know. So I've switched to just calling everything site.get on the production servers to avoid that problem. You can also avoid that problem by doing like what I was saying before and having two Git repositories. One that is like your staging copy, or one that's like the repository itself that's not a bare repository, and then the one that's actually for the production checkout. Once we've created that, we need to mark it executable. So we're going to use chmod +x post receive .sh, and now it is executable. Let's do another commit and see what happens. Now, one thing to note, it is very important that your post receive file is just named post receive, not post receive sh, not post receive anything else. Otherwise, it will not run, and it must be marked as executable. Now, our post receive file has, been bashed at the top, public HTML, and then git checkout-f. Git checkout-f is going to overwrite everything in your folder. So as we can see, the git checkout-f is running, and I can see the readme.markdown. Now, what happens if you make a change here? Well, if you make a file in here that is not in the Git repository, it will leave it alone. So not a big deal. Well, what about configuration files, you say? Well, there's a file called .gitignore, and you should look up the documentation on .gitignore because it's too much for me to get into in this video. But a file that begins with a dot and is gitignore are the files that will be ignored. So like if you set up something that requires a database or something that requires production server specific settings, you can tell Git to ignore your settings file. And actually that's a best practice anyway. You don't want to commit files that contain passwords or sensitive business information to your Git repository. That is definitely not a best practice. There are bots that farm GitHub for people that accidentally commit things like their Bitcoin wallet or their public or private keys, or passwords for the production systems, or configuration passwords, or automated deployment passwords, things like that. There are bots that look for all those passwords and will compromise those systems, and it's really easy to accidentally make a mistake. The thing I like about this system is that none of this is really on the public internet, and it's all protected through an SSH connection. It's not even through a web connection really, because again the .git folder is somewhere else, so it's pretty safe. So at this point you've got your folder hooked up, and any files that you create here you can push to production. If you do actually set up something a little more sophisticated like Laravel or WordPress or really anything, you can add stuff to that post-receive shell script so that you deploy a new database, for example, or that you run a migration, or that you do something else that is necessary once you actually check out whatever. If you make a change, like if we remove the README from production, the next time a commit runs from the dev server, a commit and a push, the file is going to be restored. The git checkout-f is going to just totally clobber anything that is in public HTML that is not committed. I've created a change on my local repository where I've added a new file. I'm going to do a git push now. It's like, oh, failed because there's changes that are on production that I don't have. So I can do a git pull. And it's like, oh, yeah, we're going to merge this. Luckily, there's no conflicts because I worked on two different files. And we can see that it's like, hey, there's some stuff here. Now I can do a git push. And now the production system should be totally in sync. So we can see, hey, here's our index.html, and we're instead of getting the list of all the files that are in the folder, I've now got a thing that says hide stuff, and when I change it, I just git push, it pushes it, it's good to go. Now, grav is something that you can do as sort of a next step that's a little bit more ambitious. Grav is a flat file CMS, meaning that the program part of it, you create the files that you want to manage, and it's templating, and it's a little bit more advanced than just raw HTML. But when you create the site, the content management system produces flat HTML files, meaning that a program is not needed to render the page. By contrast, something like WordPress, which you may have heard of, which is really popular, when you're doing something with WordPress, WordPress runs a program to actually render the page. With CMSs like Grav, they run the program and render the page and save it to a text file, so that when somebody comes along and says, hey, can you give me the page, it just gives you the text file. It's a little different philosophy than WordPress, meaning that the pages themselves are not dynamic, or if you want it to be dynamic, you need an AJAX callback or something like that. It's an interesting concept of having a lightweight, relatively secure way of having your blog or your site or whatever. With Grav, if you just use Git to commit the flat files, or you lock down the admin folder so that it's not necessarily accessible from the public side of the internet, you're in a better situation security-wise than you are with WordPress, because with WordPress, if you don't turn on automatic updates, you're probably going to be hacked inside of a month or so. And again, it's because the attack surface area for bad guys is so large because it runs executable PHP. And it has its roots in WordPress not having a super robust security architecture, which they are working on, and they've come a long way from where they were even like 3 or 4 years ago, which is really good. But there are also plugins and things like that. It's like, I'm going to download this WordPress plugin. It's like, it's not good. Now, Grav does support plugging into other Git systems with webhooks, and so you can set up Bitbucket or GitHub or GitLab, so that when you commit to your repository there, it'll phone your blog and say, hey, pull from me and set up some stuff. And that would be fun. So if you set up something with this, or you have any questions, or you sort of take it to the next step, let me know. Again, thanks to Inmotion for sort of giving me a sandbox to play around with this kind of stuff. I thought this would be a good start. I'd planned for this video to be longer and actually show you Grav and things like that, but I think this is running a bit long, and I think showing you how to get started with Git and, you know, sort of the beginnings of that and the beginnings of the philosophy of the process of, you know, automating your own stuff is maybe a good start. So maybe this is the beginning of you know, a series like our pfSense series. I don't know. Let me know your feedback and comments, thoughts, whatever, in the forum at Level 1 Text. I'm Wendell. I'm signing out, and I'll see you there.